In the flat Earth model, the Sun and Moon luminaries revolve around the Earth once every 24 hours for the Sun, and approximately 25 hours for the Moon, illuminating like spotlights the areas over which they pass. The Sun's annual journey from tropic to tropic, solstice to solstice, is what determines the length and character of days, nights, and seasons. This is why equatorial regions experience almost year-round summer and heat, while higher latitudes north and especially south experience more distinct seasons with harsh winters. The heliocentric model claims seasons change based on the ball Earth's alleged axial tilt and elliptical orbit around the Sun. Their flawed current model even places us closest to the Sun, 91,400,000 miles, in January, when it is actually winter, and farthest from the Sun, 94,500,000 miles, in July, when it's actually summer throughout much of the Earth. They say due to the ball Earth's tilt, different places receive different amounts of direct sunlight, and that is what produces the seasonal and temperature changes. This makes little sense, however, because if the Sun's heat travels over 90 million miles to reach the ball Earth, how could a slight tilt, a mere few thousand miles maximum, negate the Sun's 90 million mile journey, giving us simultaneous tropical summers and Antarctic winters? Thomas Winship said, "The Earth is a stretched-out structure which diverges from the central north in all directions towards the south. The equator, being midway between the north center and the southern circumference, divides the course of the Sun into north and south declination. The longest circle around the world which the Sun makes is when it has reached its greatest southern declination. Gradually going northwards, the circle is contracted. In about 3 months after the southern extremity of its path has been reached, the Sun makes a circle around the equator. Still pursuing a northerly course as it goes round and above the world, in another 3 months the greatest northern declination is reached, when the Sun again begins to go towards the south. In north latitudes, when the Sun is going north, it rises earlier each day, is higher at noon, and sets later, while in southern latitudes at the same time, the Sun as a matter of course rises later, reaches a lesser altitude at noon, and sets earlier. In northern latitudes, during the southern summer, say from September to December, the Sun rises later each day, is lower at noon, and sets earlier, while in the south he rises earlier, reaches a higher altitude at noon, and sets later each day. This movement round the Earth daily is the cause of the alternations of day and night, while his northerly and southerly courses produce the seasons. When the Sun is south of the equator, it is summer in the south and winter in the north, and vice versa. The fact of the alternation of the seasons flatly contradicts the Newtonian delusion that the Earth revolves in an orbit around the Sun. It is said that summer is caused by the Earth being nearest the Sun, and winter by its being farthest from the Sun. But if the reader will follow the argument in any textbook, he will see that according to the theory, when the Earth is nearest the Sun, there must be summer in both northern and southern latitudes, and in like manner, when it is farthest from the Sun, it must be winter all over the Earth at the same time, because the whole of the globe Earth would then be farthest from the Sun. In short, it is impossible to account for the recurrence of seasons on the assumption that the Earth is globular and that it revolves in an orbit around the Sun." Gabrielle Henriette said, "The essential feature of the year is its division into 2 equal periods of 6 months, based first on the predominating length of the days over that of the nights, and vice versa, conditions which are governed by the varying hours of sunrise and sunset, and secondly, by the either high or low height reached by the Sun in the heavens at midday. The first cycle, during which the days are longer than the nights, and the Sun reaches its culminating point of the year, extends from the spring equinox to the autumn equinox, i.e. March 21st to September 22nd, and the second cycle, during which, inversely, the duration of the nights exceeds that of the days, and the Sun descends to its lowest point of the year, extends from the autumn equinox to the spring equinox, i.e. September 23rd to March 20th. These 2 6-month periods are also characterized by an opposition of temperature. During the first cycle, which corresponds to spring and summer, the heat gradually rises and falls, while during the second cycle, which comprises autumn and winter, it is the intensity of the cold which progressively increases and decreases. If the Earth were truly a globe, the Arctic and Antarctic polar regions and areas of comparable latitude north and south of the equator should share similar conditions and characteristics such as comparable temperatures, seasonal changes, length of daylight, plant and animal life. In reality, however, the Arctic and Antarctic regions and areas of comparable latitude north and south of the equator differ greatly in many ways. Thomas Winship says, "If the Earth be the globe of popular belief, the same amount of heat and cold, summer and winter, should be experienced at the same latitudes north and south of the equator. The same number of plants and animals would be found, and the same general conditions exist. That the very opposite is the case disproves the globular assumption. The great contrasts between places at the same latitudes north and south of the equator is a strong argument against the received doctrine of the rotundity of the Earth. Antarctica is by far the coldest place on Earth, with an average annual temperature of approximately -57 degrees Fahrenheit and a record low of 135.8. The average annual temperature at the North Pole, however, is a comparatively warm 4 degrees. Throughout the year, temperatures in the Antarctic vary less than half the amount at comparable Arctic latitudes. The northern Arctic region enjoys moderately warm summers and manageable winters, whereas the southern Antarctic region never even warms enough to melt the perpetual snow and ice." Thomas Winship wrote, "This uniformity of temperature partly accounts for the great accumulation of ice which is formed, not on account of the great severity of the winter, but because there is practically no summer to melt it. In the Antarctic there is eternal winter, and snow never melts. As far north as a man has traveled, he has found reindeer and hare basking in the sun, and country brilliant with rich flora. Within the Antarctic Circle, no plant is to be found. The island of Kerguelen at 49 degrees southern latitude has only 18 species of native plants that can survive its hostile climate. Compare this with the island of Iceland at 65 degrees northern latitude. 16 degrees further north of the equator than Kerguelen is south, yet Iceland is home to 870 species of native plants. On the Isle of Georgia, just 54 degrees southern latitude, the same latitude as Canada or England in the north, where dense forests of various tall trees abound, the infamous Captain Cook wrote that he was unable to find a single shrub large enough to make a toothpick. Cook wrote, "Not a tree was to be seen. The lands which lie to the south are doomed by nature to perpetual frigidness, never to feel the warmth of the sun's rays, whose horrible and savage aspect I have not words to describe. Even marine life is sparse in certain tracts of vast extent, and the sea-bird is seldom observed flying over such lonely wastes. The contrasts between the limits of organic life in Arctic and Antarctic zones is very remarkable and significant. Vegetables and land animals are found at nearly 80 degrees in the north, while from the parallel of 58 degrees in the south, the lichen and such-like plants only clothe the rocks, and seabirds and the cetaceous tribes alone are seen upon the desolate beaches. In the Arctic there are 4 clearly distinguished seasons, warm summers, and an abundance of plant and animal life, none of which can be said of the Antarctic. The Eskimo live as far north as the 79th parallel, whereas in the south no native man is found higher than the 56th. W.N.R. Chambers, in Arctic Explorations, wrote, "Beyond the 70th degree of southern latitude, not a tree meets the eye. Wearied with the white waste of snow, forests, woods, even shrubs have disappeared, and given place to a few lichens and creeping woody plants, which scantily clothe the indurated soil. Still, in the farthest north, nature claims her birthright of beauty, and in the brief and rapid summer she brings forth numerous flowers and grasses to bloom for a few days, to be again blasted by the swiftly recurring winter. The rapid fervor of an Arctic summer had already, June 1st, converted the snowy waste into luxuriant pasture ground, rich in flowers and grass, with almost the same lively appearance as that of an English meadow." In New Zealand, situated at 42 degrees southern latitude, on the winter solstice the sun rises at 4:31 a.m. and sets at 7:29 p.m., making the longest day of the year 14 hours and 58 minutes. On the summer solstice, the New Zealand sun rises at 7:29 a.m. and sets at 4:31 p.m., making the shortest day 9 hours and 2 minutes long. Meanwhile, in England, a full 10 degrees farther north of the equator than New Zealand lies south, the longest day is 16 hours and 34 minutes, the shortest day 7 hours and 45 minutes. Therefore, the longest day in New Zealand is 1 hour and 36 minutes shorter than the longest day in England, and the shortest day in New Zealand is 1 hour and 17 minutes longer than the shortest day in England. William Swainson, an Englishman who emigrated and became Attorney General of New Zealand in the mid-19th century, lived in both countries for decades and wrote of their differences, stating, "The range of temperature is limited, there being no excess of either heat or cold. Compared with the climate of England, the summer of New Zealand is but very little warmer, though considerably longer. Even in summer, people here have no notion of going without fires in the evening. But then, though the days are very warm and sunny, the nights are always cold. For 7 months last summer, we had not one day that the sun did not shine as brilliantly as it does in England in the finest day in June, and though it has more power here, the heat is not nearly so oppressive. But then there is not the twilight which you get in England. Here it is light till about 8 o'clock, then in a few minutes it becomes too dark to see anything, and the change comes over in almost no time. The seasons are the reverse of those in England. Spring commences in September, summer in December, autumn in April, and winter in June. The days are an hour shorter at each end of the day in summer, and an hour longer in the winter than in England." In the flat Earth model of the cosmos, these Arctic and Antarctic phenomena are easily accounted for and exactly what would be expected. If the sun circles over and around the Earth every 24 hours, steadily traveling from tropic to tropic every 6 months, it follows that the northern, central region would annually receive far more heat and sunlight than the southern circumferential region. Since the sun must sweep over the larger southern region in the same 24 hours it has to pass over the smaller northern region, its passage must necessarily be proportionally faster as well. This is why the Antarctic morning dawn and evening twilight are very abrupt, whereas in extreme north, twilight continues for hours after sunset, and many midsummer nights the sun does not set at all. Dr. Samuel Rowbotham said, "If the sun is fixed and the earth revolves underneath it, the same phenomena would exist at the same distance on each side of the equator. But such is not the case. What can operate to cause the twilight in New Zealand to be so much more sudden, or the nights so much colder than in England? The southern hemisphere cannot revolve more rapidly than the northern. The latitudes are about the same, and the distance round a globe would be the same at 50 degrees south as at 50 degrees north, and as the whole would revolve once in 24 hours, the surface at the two places would pass underneath the sun with the same velocity, and the light would approach in the morning and recede in the evening in exactly the same manner. Yet the very contrary is the fact. The constant sunlight of the north develops, with the utmost rapidity, numerous forms of vegetable life, and furnishes subsistence for millions of living creatures. But in the south, where the sunlight never dwells, or lingers about a central region, but rapidly sweeps over sea and land, to complete in 24 hours the great circle of the southern circumference, it has not time to excite and stimulate the surface, and therefore, even in comparatively low southern latitudes, everything wears an aspect of desolation. These differences in the north and south could not exist if the earth were a globe, turning upon axes underneath a non-moving sun. The two hemispheres would at the same latitudes have the same degree of light and heat, and the same general phenomena, both in kind and degree. The peculiarities which are found in the south as compared with the north are only such as could exist upon a stationary plane, having a northern center, concentric with which is the path of the moving sun." And William Carpenter wrote, "Every year the sun is as long south of the equator as he is north, and if the earth were not stretched out as it is, in fact, but turned under, as the Newtonian theory suggests, it would certainly get as intensive a share of the sun's rays south as north. But the southern region being, in consequence of the fact stated, far more extensive than the region north, the sun, having to complete his journey round every 24 hours, travels quicker as he goes further south, from September to December, and his influence has less time in which to accumulate at any given point. Since, then, the facts could not be as they are if the earth were a globe, it is a proof that the earth is not a globe.